Teacher Jeffrey here. Welcome to our topic homeostasis. This time I would like to recognize the work of my students. Let's go and dive in now.
So today we're going to be talking about homeostasis, thermoregulation, increase in heat by Ridwan, Farrell, Dhafa, Nile, and Izzat. So what is homeostasis actually? It's the ability or tendency of a living organism, cell, or group to keep the conditions inside it the same despite any changes in the conditions around it, or the state of internal balance, for example humans, as it is able to keep the average body temperature around 98.6 Fahrenheit or around 37 degrees Celsius. And now we have thermoregulation. What is thermoregulation? Well, it's basically another form of homeostasis. It's the maintenance or regulation of temperature in your body. It's basically the process of maintaining your body core's temperature due to the state of equilibrium. And why do we need thermoregulation? Well, because the provision of a stable core body temperature is essential as many of the bodily processes carried out day to day are controlled by enzymes. The structures that are involved in thermoregulation include blood vessels in the dermis layer, hair, sweat glands, sensory receptors, and subcutaneous fat. So this is the stimulus pathway. It all begins from the stimulus, which is a change in the environment, either external or internal, that is detected by a receptor. Receptors transform environmental stimuli into electrical nerve impulses. These impulses are then transmitted via neurons to the central nervous system, where decision-making occurs. When a response is selected, consciously or unconsciously, the signal is transmitted via neurons to the effectors, which is basically the relevant body parts. And then lastly we have the response, which is a change in the organism resulting from the detection of a stimulus. So let me explain all of this in thermoregulation terms. The stimulus, which is where it all begins. Let's just say, for example, it is a warm day. The temperature receptor then detects that and sends nerve impulses to the brain. The hypothalamus of the brain is then stimulated and it sends nerve impulses the relevant body parts. This is where the corrective mechanism occurs. Atrials in skin dilate, shunt vessels constrict, more blood flows to blood capillaries in the skin, increasing heat loss. Sweat glands become more active. More sweat produce, more latent heat loss. Hair erector muscles in skin relax, and metabolic rate decreases. And then for the response, this is where the blood temperature decreases to the normal temperature. As mentioned earlier, a corrective mechanism which brings about the reverse effect of the stimulus. All homeostatic mechanisms use negative feedback to maintain a constant value called the set point. Negative feedback means that whenever a change occurs in a system, the change automatically causes a corrective mechanism to start, which reverses the original change and brings the system back to normal. Well, what happens when you have too much heat in your body? Heat exhaustion happens when your body gets too hot. If you don't treat heat exhaustion, it can lead to heat stroke. This occurs when your internal temperature reaches at least 104 degrees Fahrenheit. Heat stroke is much more serious than heat exhaustion. It can cause shock, organ failure, or brain damage. In extreme cases, heat stroke can kill you. Well, in that case, here are some of the best ways of losing heat in your body. Number one is evaporation. Let's just say when you work out and sweat, the body heat turns the sweat into vapor, cooling your body down. Convection. Similar to being exposed to cold air or air and water moving across the skin, resulting in heat loss. Conduction. It's like being in a direct contact with an object, for instance sitting or lying on the cold ground. Removes heat from the body until the ground and the body are the same temperature. Radiation. When your body radiates, the blood flows more and that results in heat loss. And finally we have respiration, which is when cold air is inhaled. That air then turns warm, which is when the body exhales it, resulting in a significant source of heat loss. And so for our last slide, we have the negative feedback. A negative feedback occurs when some function of the output of a system, process, or mechanism is fed back in a manner that tends to reduce fluctuations in the output, whether caused by changes in the input or by other disturbances. A great example of a negative feedback is thermoregulation. So let me just summarize everything that I talked about earlier. So when the body increases in heat, or also known as a stimulus, the receptor will detect it and tell the relevant body parts to perform a corrective mechanism. This will then give a negative feedback and turn the body temperature back to normal. So this is where the video comes to an end. Thank you so much for listening to our presentation. I hope you guys have a wonderful day.
This ends our featured topic for today, maintenance of the internal environment called homeostasis. The group discussed about increase in heat, which is under thermoregulation. This is teacher Jeffrey. A goal without a plan is just a wish.